hurry up, faster, come in. Whenever we sketch the graph for cos and sin, we have to find the range first. Okay, how are we going to find the range? Have a look at here. So this is the method, please follow. Cos of an angle, highest 1, lowest -1. So now I times with, you see the cos and the, here I times with -2. So whenever I times with a negative number, I must change the sign. Do you get me? So then I plus 1. So I can write my xt, I plus 1 on both sides. So then I write it back. Usually we write the inequality in this way. Okay, so that means the displacement, highest is -1, lowest is 3. Highest is 3, lowest is -1. Okay, so whenever I plot the graph, okay, so I prepare the axis. So I know that lowest is -1, highest is 3. This is my t, this is my x. And you know that for cos and sin, listen here, this is something that I want to teach you without the graphic calculator. For cos and sin curve, without any other function, just another constant or whatsoever, it definitely got 2 inflection points. And the 2 inflection point is always lie on the equilibrium point. Okay, what do you mean by equilibrium point? That means the midpoint of the highest and the lowest. Okay, so that is something about sin and cos that I know. So this is another true fact. So that means there is an equilibrium point here. Okay, so now if you take out your graphic calculator, you know that the shape of the graph go like that. Am I right? So that means the equilibrium happened at 1, the inflection point. So, and it also is the middle between the minimum and the maximum. So you know that the minimum here is 0 and the maximum here happen when x equal to pi. Am I right? So that means the equilibrium will happen at pi/2 for this case. So here is your pi. Here is your 2 pi. Here is your pi/2. Here is middle of pi and 2 pi is 3 pi/2. So start with the lowest, go to equilibrium, go to the highest, come back to the equilibrium, go to the lowest. So when you sketch the trigo function for sin and cos, you have to be very careful. Your graph is a bit flattened at the beginning, then very sharp at the inflection point. Then same go with here. Here have to be a bit flattened. Then go like that. Your shape is very important. This part is concave down. This part is concave up. So here you put 2 pi, -1, 0, -1, and here is pi 3. So you get a complete graph, you get 2 marks for doing it. So if I continue, this is called one full cycle. If I continue the time, then it will go on and on. So if this motion, listen here first, don't keep doing that one. If this motion, I draw a motion diagram. This is the origin. It will start from -1 here. It will move to the right. Then after t equal to pi, this is t equal to 0. Then it will turn it will come back to here, t equal to 2 pi. If you continue again, it will just do like that. This is the motion diagram. That means it oscillates between 2 points. It goes like that, like that, like that, like that. So usually, when we find total distance travel, actually, or we find when it stopped moving or whatsoever, correct? We usually use the graph. We don't use the sign diagram or the motion diagram. So that's why for trigo, when you talk about kinematic, correct, graph of displacement is the best way to interpret everything. So this is called one cycle. So another 2 pi, another cycle, another 2 pi, another cycle. It repeated itself. So this is the characteristic of a trigo function. Clear? This is called the motion diagram. So usually we don't use motion diagram to find the total distance travel. Like for example, in this case, I say, what is the total distance travel in the 2 pi second? You know that is 4 plus 4, that is 8. Am I right? From -1 go to 3 is 4. From 3 go to -1 is another 4. If I'm talking about total distance travel in the 4 second, then in the 4 pi second, then there will be 144, 244, 344, 444, 16. So that is how you calculate. So this will be the distance travel in half a cycle. So when you talk about trigo function for kinematic, you must understand that it's an oscillation. Oscillation can be vertical oscillation, can be horizontal oscillation. Clear? Okay, so this is something that I want to point out to you if they happen to ask in the exam. Give you some idea of a trigo function first, how it works. So this graph is a very important, that's why I keep stretching. You must learn how to sketch the graph, and I'm going to use this graph to help me to solve all the questions there. Okay? Hello? Okay. So can you please take some time to solve A, B, C, and D? Question 8. Okay. Every time when you want to solve a kinematic question, I told you already, you must first key in your y1 as your xt. Yeah, that is 1 minus 2 cos x. And your y2, you must key in as this one. Which is vt, because vt is x prime t. And your y3 must key in as this. That is your AT, which is your V prime T, which is your X double prime T. So this is a revision. Okay, so from there, please make full use of your graphic calculator and get the answer for all. Those who learn SpecMax, you better learn how to sketch the graph without the graphic calculator. Part A and B, you can use the graphic calculator to help you to calculate the value, okay? Initial means T equal to 0. Correct? Chemistry. 一点铁链、条线、明确、明线、明线。 Okay, are you done? Okay, for part A, listen here. If I write in my answer, I wrote down all this, correct? I wrote down all this in my question, correct? So I can straight away state the initial position. So I can straight away write y1, 0. Are you clear? If not, you cannot write. You have to write x 0. But if you didn't write down this in your answer, you have to write down x 0. So x 0, it will be -1. So this is the initial position. It is 1 unit to the left of the origin. Okay, then you want initial velocity. That means this is your y20. Yep, and y20, you should get 0. Am I right? cm per second. That means it starts with stationary. Yep. Then initial acceleration will be a y30. That is a0, which is 2 cm per second per second. Okay, now if I am using calculus, look, so my xt is equal to 1 minus 2 cos t, right? So x0 will be equal to 1 minus 2 times cos 0. So 1 minus 2 cos 0 is 1. So I get -1. Okay, so my VT, I have to differentiate this. So when I differentiate cos, I get negative sin, am I right? Okay, so this is 2 sin t. So this is my calculus. So V0 will be equal to 2 times sin 0, which is 0. Right? Okay, then your AT will be equal to 2. You differentiate sin, you get cos. Right? So therefore, A0 will be equal to 2. So if the question said by calculus, then you have to differentiate and substitute in. Are you clear? If the question didn't say, then you don't have to. Got it? Okay. So for part B, what you can do is, you want to describe the motion, so you have to find x pi by 4 first. You can use your GC. If the question asks for exact, then what should I do? Exact value. Okay. So x pi by 4. So what the question give you is, what is the answer? -0.414. Okay, negative 0.414. V pi by 4. Yeah, I know. 1.414. And A pi by 4, 1.414 also. But the unit of measurements are the different. So now you say that at t equal to pi by 4 second, the object is 0.414 cm at the left of Joshua. What are you doing? Are you sure? You keep looking at your screen. At the left of the origin and moving. Joshua, continue. Moving to the right with the speed of continue, Joshua. I'm waiting for you. 1.414 cm per second. And you can say accelerating at that value. Okay? If you don't want, you can stop there. It's fine. Okay. Now, if you talk about exact value, then you have to go back to your formula. This is equal to 1 minus 2 cos pi by 4. Every one of us should know what is the exact value of cos pi by 4 and sin pi by 4. They are the same. So which is either you can write is 1 over root 2 or you can write it as root 2 over 2. This one is a must to know because if the question asks for exact displacement and you can't give me, then it's too bad. So this is 1 minus 2 times root 2 over 2. So this is 1 minus root 2. That's why I know it's negative 0.414 because the approximate value of root 2 is 1.414. All maths teacher memorized by heart already. Nothing new. Every day we press the calculator, we know. Okay, your V pi by 4. So you have to go back to your V formula, which is 2 sin t. Clear? So I write down, this is equal to 2 sin pi by 4. So this is 2 sin pi by 4 is root 2 over 2. So the exact value will be root 2 cm per second. So it's a must to know exact value. If not, then you will be in trouble. Do you get me? So it just need your effort to write this one down in your notes. Okay, so acceleration. We know that acceleration is 2 cos t, correct? So pi by 4. So this is 2 root 2 over 2. So that's why it's the same value. So the exact value of some special angle, you better remember it or you better write down in your notes. You get me? Okay, done. Yep. So let's move to part C. Okay, find the time when the particle reverses its direction within 0 and 2 pi. So if you go back to the graph, you should know that it happened here. Am I right? So you can just write down, and you also know the displacement, correct? So you can straight away write down the answer. You just say Vt equal to 0, so t equal to pi. So therefore, x pi is equal to 3. So you answer the question. Okay, I'm going to teach you how to do part D by referring to the graph. Okay, now, for part D, when the particle speed increasing, it happened at when xt is increasing with increasing rate, or xt is decreasing with increasing rate. So just now we had the graph from here, 0, -1, it go up to pi by 2 and 1, correct? You see this part is increasing with increasing rate. Then after that we have like that until this inflection point. This is pi and 3. This is 3 pi by 2 and 1. Then you go down. So look, increasing with increasing rate is this part. You see? The gradient becomes steeper, means the speed is increasing. This part, the gradient also becomes steeper. So I can straight away from the graph, I can give the answer without drawing the sign diagram. So therefore, t is between 0 and pi by 2, or t is between pi and 3 pi by 2. See or not? Now, I'm going to go a step further. I'm going a step further to tell you that if I change the question like this, find the time, the range of time, the interval. Find the range of time for t between 0 and 4 pi, for example, when speed is increasing. Okay, so how am I going to do this? Look here. We know that for this function, each cycle is 2 pi. So 4 pi means it get into the second cycle. So my answer for this one will be this answer. And the next cycle, everything I plus 2 pi. Do you get me? So this is the second cycle. That is how it goes. Because if I draw the graph, you look, I sketch the graph for you to see. It go like that. This is one cycle, stop here at 2 pi. Then after that, it continue with the next cycle and it end at 4 pi. Isn't it become from pi to 3 pi by 2? Isn't it the gradient becomes steeper from here? Put your pencil there, put your pencil here, put your pencil here. Isn't it called become steeper? That means I will say that the velocity change from, okay, from 0 to 3 to 2, from 3 to 4 to 5. The speed is increasing, the gradient, the velocity is decreasing because the velocity change from -2 to -3 to -4. Speed is without the absolute sign. Hello? Velocity is decreasing, but the speed is increasing if the velocity is negative. From -2 go to -3, go to -5. That is how you imagine. Are you clear? So remember, trigo always go in cycle. So if you want to draw sign diagram of velocity and acceleration, you're going to kill yourself for it. So I say graph interpretation for trigo will be the best. They give you the figure, you can look at it and you can imagine. So it go in one cycle. One cycle is, some of them, one cycle is pi, depend on the situation. So you sketch the graph, you will know the cycle. You get from the starting point, go round and round, come back to the same point. That is called one cycle. Then after that, you repeat the same thing again. That is called second cycle. So are you clear?